Welcome back. We're now on Unit 1, Segment 3, page 3 in the lecture notes. Remember, this is just our little review on math, numbers, and general concepts. Rounding and digits. Hopefully you remember from your basic class that the way you round and express your number that you write on the page is an expression of how certain you are of that answer. And by that, I don't mean pushing buttons on your calculator, certain, but the certainty of the measurement, which is why we pay particular attention to rounding and digits. So if I have a number like this and I ask you to round to the 10th place, I assume you know what the 10th place is, so I'm not going to belabor that. But as a matter of standard practice, what I always do is I put a vertical line where I want to round so that my mind doesn't play tricks on me, because you either round properly or you don't. Since 7 is greater than 5, we're going to round this up and we're going to express this to 34.7. If I want to round 104.8 to 3 digits, 1, 2, 3 digits, my vertical line, the 0.8 means I round up, and I will express this as 105. 11.3 to 2 digits, 1, 2. The 3 means this drops off, and this just gets expressed as 11. So far, so good, not so hard. But if I say round 457 to 2 digits, most people will write that as 46. And you can think in terms of dollars, for example. People are very well aware of the meaning of dollars, and you could ask yourself, is $457 the same as 46? And the answer, of course, is no. From a mathematical and chemistry standpoint, what you need to do is to keep the 4 in the hundreds place. The 4 right here is not in the hundreds place, it's in the tens place. So I have to put a 0 here as a placeholder to put the 4 back into the hundreds place. And you might ask yourself, well, isn't the 0 here a quote-unquote digit? And the answer is, as I've written it, no. So we're going to come back to that when we talk about significant figures and remind ourselves about what those are. Okay? Log base 10, which is the reciprocal function of 10 to the x. Okay, so the logarithm, log base 10, is the reciprocal function of this. We'll talk about log base 10 when we get to pH. Now, there are some certain definitions that I'm not going to reinvent. I'm not going to reinvent the wheel on this. They're found in your textbook. If your textbook doesn't have it, there's always the magic of Google. Scientific method, you should understand that it begins with the observation. And observation doesn't necessarily mean cause and effect. Other definitions that you need to be responsible for are physical versus chemical changes, physical properties versus chemical properties, classification of matter, solid, liquid, gas. What does that mean? What is a pure substance? What is a mixture? Homogeneous, heterogeneous, accuracy, precision, data, and results. Okay, so this is going to be your job, and I'm not going to spend any time reviewing this because it's very well represented in a textbook. Okay, next page. Significant figures in scientific notation are the bane of the chemistry student's existence. Not all numbers that you write on a page are created equal, and this is very confusing for students, okay? Just because we push buttons on our calculator doesn't mean we're justified in reporting it, okay? This is a very, very different concept. So let's say this picture here, I might say this is opening day of football at Lambeau Field. Now, I'm going to admit I'm not a football person, so I don't really know if I'm making up ridiculous numbers, but most people have gone to a sporting event. And if I said, gee, look out into the crowd and tell me how many people there are attending that event. And let's say you say 65,112 just by sitting in your chair trying to count. Well, that's a ridiculous misrepresentation of the certainty of that, because even if you could count everybody, you wouldn't account for the ebb and flow of people coming into the bathroom or getting sick and deciding they're going to leave, or somebody who might, you missed because they were small in the seats or whatever. You have no idea. What you might be able to say is that the stadium holds about 65,000 people, and therefore I think there's about 65,000 there. This would be reasonable. This would be ridiculous. Okay, our guy with his money over here, let's say he just won the lottery. And let's say we look at that pile of money and we say that the guy won $112,629,416.03. Well, that would be totally ridiculous based on what we see here. We don't even know what's in these bags. We don't know what's inside the pile. We don't know if they're dollar bills, $100 bills. This is utterly ridiculous. If he had a check, if his check had this value, well then yeah, all those digits would matter. But just by looking at this pile, that is absurd to come up with that number. Now we're going to contrast it with this picture. Let's say I look at this picture and I assume this is just a doll and not a family member. 1, 2, 3, 4, 5, 6. I see 6 people in that picture. That is an accurate representation of what I'm seeing there. 1, 2, 3, 4, 5, 6, 7 $100 bills. If I write 700 with these 2 zeros here, there's nothing in his hand, there's nothing in his pockets, he's just holding 7 $100 bills. That is an accurate representation of what I'm seeing and measuring there. So the question is, well, how can you tell when to report the digits? Do I report all these? No. Do I report all these? No. Do I report that one? Yes. Do I report all of these? Yes. Well, there are rules. There are rules for this, and this should not be new. Okay? This should absolutely not be new. Your prior chemistry course